the easy Pythagorean identity is understanding, like, basically when we have, like, on the unit circle, we know that the radius is 1. And that coordinate is x, that's y. And then we'd say the x over y of that angle theta. And if we were talking about sine and cosine, we'd say sine is y over 1, which was really just y, right? Yes? And that's where we say cosine is adjacent over hypotenuse, which is really just x. Correct? Right? Well, so we could also say, if what we said is, the sine of theta equals y, and the cosine of theta equals x. Yep, I mean, this is something from pre-calculus for you guys. Yes? Yes, I mean, some of you guys. And then, I mean, obviously the easy one to always remember, and that's a lot of it because it just relates to the Pythagorean theorem. X squared plus y squared equals 1. You guys would agree, right? X squared plus y squared equals 1. Pythagorean theorem. Well, if I know that cosine of theta equals x squared and sine of theta equals y squared, then I could really say cosine squared of theta plus sine squared of theta equals 1. And that was something I wrote down with there, you guys. And it's like, you should have memorized. And that's usually the way that I would always introduce knowing that. And I didn't really ever have to remember that because, even though I've been gone from school for so many years, like I remember sine squared plus cosine squared equals 1. That was just automatic. The ones that always tricked me were the cotangent, the secant. Like, how do I remember those? I always kind of seem to like forget them. And then furthermore, I was like, you know what? I actually never was interested in like where they came from or why this makes sense, like so much sense to me at least. Yes? I mean, do you guys like, there's not much like changing that you have to do to understand. This is just the Pythagorean theorem with different representation of like the side lengths, just using cosine instead of x. But then I came across this, and I was like, oh, wow, this actually makes things so easy. So you guys would agree that 3 times 4 is equal to 12. That is what we call an identity. Even though they don't look like the same on the left and right side, the left side is equal to the right side. Yes? And even if we are solving, the main important thing, guys, is we learn the properties of equality. As long as you apply the properties of equality to everything on the left side to everything on the right side, you maintain the identity, right? You maintain that equality. Would everybody agree? OK. So here's where the cool thing. I was like, oh my god, I'm never going to forget these identities ever again. So what happens if I have cosine squared of theta plus sine squared of theta equals 1? You guys would agree it's OK if I was to say, well, you know what? Why don't we divide everything by sine of theta? Right? I mean, who knows why somebody would want to ever do that. But it's OK, let's do that. So therefore, I get cosine squared of theta over sine squared of theta plus sine squared of theta over sine squared of theta equals 1 over sine squared of theta. Now let's simplify this using the reciprocal identities. Remember you guys walked in, we had all those identities there. This is actually a quotient identity. Cosine over sine is cotangent squared of theta. Sine over sine is 1. 1 over sine is cosecant squared of theta. That's your other Pythagorean identity. Oh, I was like, oh, I never made that relationship thing. It was like, it's cool. It's on my 34th birthday. I figured that out. All right, on the next one. That was yesterday. You guys didn't bring me cake, though. For the next one, let's just do this, because we'll need this for the next example. Cosine of theta plus sine squared of theta.
Was it actually yesterday?
Yeah. You guys know? Thank you. Anyways, so let's go ahead and do the same thing, but let's do by cosine. Therefore, this gets 1. Tan equals secant squared of theta. I know my handwriting is a little scratchy. Yeah, but what I'm saying is if you remember cosine, if you have, like me, I have ingrained in my brain sine squared plus cosine squared equals 1. Right? From the time I learned it in high school pre-calculus to the time that I started teaching high school pre-calculus, I had that just ingrained sine squared plus cosine squared equals 1. It was very easy to remember, and I had it. So I could never remember these, though. They always trick me up. So now I just think, well, why don't I just take what I remember and just divide it by sine and divide it by cosine to real good, like just to then I can get them really quickly on my own. I don't have to like memorize them or spend time doing flashcards and like doing that. I can just derive them on my own. Okay? So I thought that was very interesting. I figured I'd even take 5.